Comet 3I/Atlas, a wake-up call for humanity and space exploration. By Rafi Glick. Comet 3I/Atlas, a wake-up call for humanity and space exploration. The interstellar visitor 3I/Atlas is not just another unusual comet. It is a strange neighbor that temporarily entered our solar system, approached Earth as closely as December 19th, and is now receding, unlikely to return for hundreds of millions of years. Its very appearance forces humanity to pause and confront how small, vulnerable, and above all, unprepared we truly are. The central question posed by 3I/Atlas is not whether life exists elsewhere in the universe, but how many worlds similar to our own already exist. Current estimates suggest that the Milky Way alone may host around 1 billion Earth-like planets. In just the past decade, 3 interstellar objects have been identified passing through our solar system. Oumuamua, 2017, Borisov, 2019, and now 3I/Atlas, 2025. With the completion and full calibration of the world's most powerful survey telescope, the Vera Rubin Observatory, we are likely to detect such interstellar visitors at a rate of 1 every few months. This new reality demands global analysis and preparedness, not only scientific, but also cultural, educational, and strategic. 1. Anomalies are not proof. They are a wake-up call. Over the past months, roughly 15 anomalies have been identified in the behavior of 3I/Atlas that cannot be fully explained using standard models of comets originating within our solar system. It is crucial to emphasize, anomalies are not proof. They are signals that require examination within a broader and more complex framework. Direct comparisons between local solar system bodies and interstellar objects can be misleading. 3I/Atlas is likely 8 to 13 billion years old, older than our solar system itself. There is no reason to expect it to conform to models derived from observations of much younger objects. A clear illustration comes from the DART experiment. When a NASA spacecraft deliberately collided with the asteroid Dimorphos, the resulting debris was documented by the small Italian spacecraft LHCube. Subsequent analysis conducted under ESA missions revealed that the debris behaved in ways that diverged from established theoretical expectations. In other words, even with local objects, we encounter unexpected behavior. All the more so when dealing with an ancient interstellar body. 2. Natural or technological. Not probability, a cumulative process. The question of whether an object is natural or technologically influenced cannot be resolved through popular probability rankings. This is not a smooth spectrum of more natural versus more technological, but a cumulative scientific process of collecting, analyzing, and weighing evidence. One can think of it as a set of scales. On one side, findings supporting a natural explanation, on the other, anomalous observations. Only when clear, robust evidence accumulates does a conclusion emerge, a process that may take months or even years. Even a very low probability, 1% or less, justifies preparedness. The potential scientific and possibly cultural implications are enormous. Some of the data from 3I/Atlas has yet to arrive, and analyzing what has already been collected is expected to take considerable time. 3. What is truly missing? A global strategy. The central problem is not 3I/Atlas itself, but the absence of a global institutional framework for dealing with interstellar objects. Astrophysics as an academic field must expand, and this knowledge must flow into educational systems and reach younger generations who are currently making decisions about their future paths. Instead of theoretical disputes, a new institutional approach is required. A global strategy for interstellar objects, analogous to existing planetary defense mechanisms. The natural framework for such coordination is the United Nations, which already hosts international mechanisms for monitoring cosmic threats. This approach does not depend on what the object ultimately turns out to be, but on what can be learned from it, how it should be assessed, and which tools are needed for prediction and decision-making. 4. Every encounter is a one-time opportunity. Even without determining whether the phenomenon is natural or artificial, the scientific opportunities are extraordinary, transmitting data and information that may continue traveling through interstellar space. Collecting ancient information, An object like this may have seen Mars billions of years ago, when water and potentially life existed there. Sending signals of goodwill as a scientific cultural exercise, not a declaration. Turning the object into a mobile research platform using cameras, sensors, and detectors. Employing long-term technologies such as lasers, radio signals, and interstellar communication methods, as I proposed in earlier articles in October 2025. An interstellar body like 3I/Atlas releases jets of dust and gas over hundreds of thousands of kilometers during a journey spanning billions of kilometers through the solar system. It disperses vast quantities of material, some of which reaches Earth's atmosphere and other planetary bodies. Even if only a small number of interstellar objects pass through the solar system each year, over its lifetime, trillions of such bodies would have traversed it, dispersing thousands of quadrillions of tons of material. Not answers, but a process. There are no final answers here, nor should there be. This is not a task for a single researcher or a single nation, but a collective effort involving astrophysicists, space engineers, philosophers of science, and policymakers. The challenge posed by 3I/Atlas is not whether it is alien. It is whether humanity is capable of thinking, organizing, and acting on an interstellar scale and over the long term.